Imagine a book filled with words nobody can read. It's not written in a lost language we once knew. It's written in symbols that look like a language, but one that has never been seen anywhere else. This book is a whisper from an unknown past. It teases us with secrets it refuses to share. For over a century, this manuscript has challenged the brightest minds. It sits there, a silent testament to an unsolved cosmic or perhaps merely human puzzle. Its pages hold a story, a theory, or maybe just an elaborate jest, and we are still knocking at its unopened door, eager for a glimpse inside. This mysterious object is called the Voynich Manuscript. Its modern story begins in 1912. A Polish-American antique book dealer named Wilfrid Voynich stumbled upon it. He found it hidden within a collection of old texts at the Villa Mondragone, a Jesuit college near Rome. Voynich was immediately captivated. He knew this was no ordinary book. Its script was alien. Its illustrations were bizarre. He dedicated much of his life to uncovering its origins and meaning. He believed it held profound knowledge, locked away by its strange text, waiting for the right key to unlock its wisdom. The manuscript itself offered no easy clues, its history prior to its discovery by Voynich remaining largely shrouded in speculation and tantalizing hints from old letters. The manuscript itself is a physical artifact, a codex of about 240 vellum pages. Many pages are filled with a flowing, elegant script. This script uses an alphabet of unique characters, some resembling Latin letters or numbers, others entirely novel. Interspersed with the text are intricate drawings. These illustrations are as baffling as the script itself. There are sections depicting unidentifiable plants, their roots and leaves drawn with careful detail, yet matching no known species on Earth. Other pages show astronomical charts with strange suns, moons, and constellations. Perhaps most curious are the balneological pages, featuring many small, naked figures, predominantly female, bathing in elaborate networks of pipes and green-tinged pools. From the moment of its rediscovery, the Voynich manuscript presented an immediate and profound puzzle. It was a cryptographer's dream, or perhaps nightmare. Scholars, linguists, mathematicians, and amateur sleuths have all tried to crack its code. Is it a cipher, masking a known language? Is it an artificial language, constructed with its own grammar and vocabulary? Or could it be a meaningless hoax, cleverly designed to appear profound? The manuscript's allure lies in these unanswered questions. It's a challenge to our understanding of communication, history, and the human desire to find meaning. Its silence speaks volumes about the limits of our knowledge and the enduring power of mystery. After Wilfrid Voynich brought the manuscript to public attention, a wave of fascination swept through academic circles. The quest to understand its secrets began almost immediately. The early 20th century was a time of great breakthroughs in science and scholarship. There was a palpable optimism that any puzzle, no matter how complex, could eventually be solved with enough intellect and perseverance. The Voynich manuscript, with its beautiful script and enigmatic drawings, became a prime candidate for such scholarly conquest. It was a new frontier in historical and linguistic research. Many hoped to be the first to unveil its hidden truths, to bring its lost knowledge into the light of the modern world. One of the earliest and most dramatic attempts at decipherment came from William Romain Newbold. He was a respected scholar and dean of the graduate school at the University of Pennsylvania. Newbold became utterly engrossed by the manuscript in the 1910s. He spent years poring over its pages, his eyesight failing due to the intense scrutiny. He believed he had found the key, not in the main characters of the script, but in tiny, almost invisible markings within them. These were strokes he thought were a form of micrography, minute shorthand symbols hidden from the casual observer. This painstaking work led him down a very specific path of interpretation. Newbold's theory was sensational. He proclaimed that the manuscript was the work of the 13th century English philosopher and scientist, Roger Bacon. Bacon was a figure known for his forward-thinking ideas and rumoured experiments in ciphers and optics. Newbold claimed his micrographic decipherment revealed Bacon's groundbreaking scientific discoveries. These included observations made with a telescope centuries before its accepted invention, showing spiral nebulae. He also found descriptions of biological cells seen through a microscope, again long before its historical development. If true, the Voynich manuscript would rewrite the history of science, proving Bacon an even greater visionary than previously imagined. The initial reaction to Newbold's claims was one of considerable excitement and intrigue. His academic standing lent weight to his pronouncements. The idea of Roger Bacon encoding revolutionary scientific knowledge far ahead of his time was a romantic and compelling narrative. It fit the image of Bacon as a misunderstood genius. Newbold presented his findings in lectures and publications, captivating audiences with the tale of his decipherment and the secrets it supposedly unlocked. For a brief period, it seemed the Voynich mystery was solved, revealing a lost chapter in the saga of human intellectual achievement. The universe, it seemed, had allowed a peek into a mind far ahead of its era. However, not everyone was convinced by Newbold's elaborate theories. Among the skeptics was John Matthews Manly. He was a distinguished professor of English at the University of Chicago, known for his expertise in Chaucer and medieval literature. Manly possessed a keen analytical mind and a rigorous approach to textual scholarship. He was not easily swayed by sensational claims, preferring to rely on solid evidence and careful methodology. When Newbold's decipherment began to gain traction, Manly decided to take a closer look himself. He approached the manuscript not as a cryptographer initially, but as a scholar accustomed to the intricacies of ancient texts and the pitfalls of their interpretation. Manly undertook a meticulous examination of Newbold's work, focusing on the supposed micrographic elements. He published his findings in 1931, several years after Newbold's death. His critique was devastating. Manly argued convincingly that the tiny marks Newbold interpreted as shorthand were in fact nothing more than natural cracking and crazing of the old ink as it dried and aged on the vellum. He demonstrated that similar features could be found in many medieval manuscripts. There was no deliberate system of micrography, just the random patterns of material decay. This undermined the very foundation of Newbold's entire decipherment. Furthermore, Manly pointed out severe flaws in Newbold's proposed translation. The process by which Newbold derived Latin letters from the microscopic marks and then arranged them to form words and sentences seemed arbitrary and highly subjective. It appeared that Newbold was finding what he wanted to find, projecting his own expectations onto the ambiguous shapes. Manly also questioned the historical plausibility of Bacon possessing such advanced knowledge of astronomy and biology. While Bacon was indeed a brilliant thinker, the discoveries Newbold attributed to him were simply too anachronistic, too far removed from the scientific context of the 13th century, even for a genius. The impact of Manly's critique was profound. It effectively dismantled Newbold's theory, which had been built on such painstaking yet ultimately misguided effort. The academic world largely accepted Manly's conclusions. The Voynich Manuscript, once seemingly on the verge of yielding its secrets, was returned to its status as an unsolved enigma. Manly's work served as a crucial corrective, emphasizing the need for rigor and objectivity in the face of such a tempting puzzle. It highlighted how easily one could be led astray by enthusiasm and the desire to uncover something extraordinary. The debate it sparked reinforced the manuscript's formidable nature, a challenge that would require more than just imagination to overcome. Enter William Frederick Friedman. If anyone could crack the Voynich manuscript, many believed it was him. Friedman was a titan in the world of cryptography. His career spanned decades, starting before World War I and continuing through World War II and into the Cold War. He is legendary for his work with the U.S. government, particularly for leading the team that broke Japan's purple cipher machine, a feat of immense intelligence and mathematical insight that significantly impacted the course of the war. Friedman wasn't just a codebreaker, he helped establish the scientific principles of modern cryptology. His mind was a finely tuned instrument for dissecting patterns and uncovering hidden meanings. Friedman first encountered the Voynich manuscript in the 1920s. Likely through the publicity surrounding Newbold's work and Manly's subsequent refutation. The manuscript captured his interest immediately. It was a challenge unlike any military or diplomatic code he had faced. Those codes were designed by humans to be eventually broken by other humans, given enough skill and resources. The Voynich manuscript, however, presented a different kind of problem. Its very nature, whether it was a code, a language, or something else entirely, was unknown. This profound ambiguity fascinated Friedman, and he would return to it repeatedly throughout his long and distinguished career. In the early 1940s, during the height of World War II, Friedman assembled an informal group of expert cryptanalysts to tackle the Voynich Manuscript. This came to be known as the First Voynich Manuscript Study Group, FVMSG. Its members included some of the best codebreakers in the U.S. government, individuals who were at the same time grappling with the most sophisticated Axis ciphers. They brought their collective expertise and systematic approaches to bear on the strange script. Their goal was to apply rigorous cryptanalytic techniques, hoping to find patterns that had eluded previous, less structured efforts. They transcribed portions of the text, performed frequency analyses, and searched for underlying linguistic structures. Despite his unparalleled success in breaking contemporary codes, Friedman found the Voynich Manuscript to be an incredibly stubborn opponent. He and his group spent considerable time and effort, but a full decipherment remained elusive. One of Friedman's significant early hypotheses was that the manuscript was not a simple substitution or transposition cipher overlying a known language. Instead, he leaned towards the idea that it might represent an early attempt at a philosophical or artificial language, a language constructed from scratch, with its own unique vocabulary and grammar. This idea, that it was a synthetic language, would influence Voynich research for decades to come, showcasing the depth of the puzzle it presented even to the world's foremost cryptologist. Section 5. The NSA takes a look: Friedman's legacy and institutional efforts. William Friedman's fascination with the Voynich manuscript did not wane after his official retirement from government service. He continued to ponder its mysteries, his personal files filled with notes and analyses. His towering reputation within the cryptologic community meant that his interest in the manuscript naturally extended to the institution he helped build, the National Security Agency, or NSA. The NSA, America's premier signals intelligence organization, possessed unparalleled resources and a concentration of cryptanalytic talent. It was almost inevitable that this enigmatic text would, at various times, capture the attention of those working within its highly secure walls, carrying on Friedman's legacy of tackling the toughest codes. Following Friedman's lead, informal study groups and individual researchers at the NSA periodically took up the challenge of the Voynich manuscript. While not an official, high-priority project consuming vast agency resources, the manuscript represented an irresistible intellectual puzzle for code breakers. These efforts were often undertaken in spare time or as training exercises. The NSA had access to early computers and sophisticated statistical tools, far beyond what was available to earlier researchers like Newbold or even Friedman in his initial studies. They hoped these advanced capabilities might reveal patterns or structures invisible to the naked eye or manual analysis. The allure was to conquer a mystery that had stumped so many for so long. The NSA's cryptanalysts applied a battery of techniques to the manuscript. They conducted detailed statistical analyses of character frequencies, digram and trigram occurrences, those are 2- and 3-letter combinations, and word patterns. They searched for any underlying linguistic regularities that might point to a known language family or a specific type of cipher system. They compared its statistical profile to various known languages and types of encipherment. The hope was that the manuscript's unique fingerprint would match something in their vast experience with codes and languages from around the world. This was a systematic, data-driven approach, leveraging the agency's core competencies. Despite the formidable expertise and advanced tools at their disposal, even the NSA's analysts found the Voynich manuscript to be remarkably resistant to decipherment. The text exhibited certain language-like properties, such as Zipf's law. The frequency of any word is inversely proportional to its rank in the frequency table, but it also contained baffling features. For instance, some words repeated with unusual frequency, while others appeared only once. The entropy of the text was also peculiar, sometimes appearing too regular, sometimes too random. The efforts, though extensive, did not yield a breakthrough. The manuscript continued to guard its secrets, its complexity deepening the enigma even for the nation's top codebreakers. Section 6. New Eyes on Old Pages. Mary D'Imperio's Comprehensive Review. As interest in the Voynich manuscript persisted within circles like the NSA, the need for a consolidated overview of past efforts became apparent. This task fell to Mary D'Imperio, a computer scientist and analyst with connections to the intelligence community. D'Imperio was not primarily a cryptographer, but she possessed a sharp analytical mind and a talent for synthesizing complex information. She took on the significant challenge of reviewing the vast, often disparate body of research that had accumulated around the manuscript over several decades. Her work was crucial in providing a clear and accessible summary of what was known, what was theorized, and what remained deeply mysterious. In 1978, D'Imperio produced a monograph titled The Voynich Manuscript and Elegant Enigma. This publication, initially circulated within the NSA and later made more widely available, became a cornerstone for subsequent Voynich research. It meticulously documented the history of the manuscript, the various attempts at decipherment from Newbold onwards, and the numerous theories about its origin and nature. D'Imperio carefully presented the findings of Friedman and his study groups, as well as other independent researchers. Her work was not about proposing a new solution, but about clearly laying out the problem and the landscape of previous attempts to solve it, creating a foundation for future explorers. D'Imperio's review highlighted several key statistical properties of the Voynich text that any successful decipherment would need to explain. She discussed the distinct character set, the word-like structures separated by spaces, and the apparent organization of the manuscript into different sections based on its illustrations. She noted the peculiar repetition of certain character sequences and the overall smoothness of the text, which some argued was uncharacteristic of many complex ciphers. Her analysis brought together the linguistic, cryptographic, and codicological aspects of the puzzle, offering a holistic view. She emphasized the patterns that made it seem like a real language, yet simultaneously resisted all attempts at reading it. Ultimately, Mary D'Imperio did not offer a definitive answer to the Voynich riddle. Instead, her elegant enigma underscored the profound difficulty of the problem. She concluded that the manuscript was unlikely to be a simple substitution cipher of a known European language. The possibilities, she suggested, ranged from a sophisticated polyalphabetic cipher to an unknown natural language written in an invented script to an artificial language, or even an elaborate and meaningless hoax. Her careful, balanced assessment helped to frame the ongoing debate and provided a vital resource for anyone daring to venture into the labyrinthine world of Voynich studies, ensuring that new researchers could build upon past knowledge rather than repeating old mistakes. Section 7. 2 scripts or 1. Prescott Currier's insightful division. Another significant contribution from the mid-20th century came from Prescott Thorpe Currier. Currier was a U.S. Navy cryptographer who, like William Friedman, had a distinguished career breaking codes during World War II and the Cold War. He brought his practical experience and keen observational skills to the Voynich manuscript in the 1970s. Working independently, he conducted his own detailed analysis of the script and its distribution throughout the volume. His findings added a fascinating new layer of complexity to the already baffling puzzle, suggesting the manuscript might not be as monolithic as previously assumed by many researchers. Currier's most striking observation, presented at an informal Voynich manuscript symposium in 1976, was that the text appeared to be written in two distinct, though related, hands or languages. He dubbed these Currier A and Currier B. This wasn't just a matter of slightly different handwriting from the same scribe. Instead, he found consistent statistical differences between sections of the manuscript. These differences manifested in the preferred characters used, the common sequences of characters, n-grams, and the overall feel of the script in different parts of the book. It was a subtle but persistent distinction that had largely gone unnoticed before his focused analysis. The characteristics of Currier A and Currier B were quite specific. For example, certain letter forms or combinations might be common in sections written in Currier A, but rare or absent in Currier B, and vice versa. These two styles also seem to correlate with the manuscript's thematic sections. For instance, many of the herbal and pharmaceutical sections might predominantly feature one style, while astronomical or balneological sections might feature the other, or a mix. This suggested a deliberate organization, or perhaps contributions from different sources or scribes, using slightly different conventions, or even dialects of the underlying unknown language or cipher system. The implications of Currier's findings were significant. If there were indeed two distinct languages or scribal conventions at play, it complicated many existing theories. Was it the work of two different authors, or a single author using two different systems, or perhaps an attempt to represent two related dialects? Currier's A-B distinction became a fundamental consideration for subsequent research. Any new hypothesis about the manuscript's nature would now need to account for this observed duality. His work provided a new way to parse the text, offering potential avenues for breaking it down into more manageable, internally consistent segments for analysis, further deepening the intrigue surrounding this most mysterious of books. Section 8. The Digital Detective: Modern Computational Cracking Attempts. The dawn of the digital age and the exponential growth of computing power have ushered in a new era of Voynich manuscript research. What was once painstakingly analyzed by hand or with rudimentary mechanical calculators can now be subjected to the relentless scrutiny of sophisticated algorithms. Modern computational approaches leverage techniques from artificial intelligence, machine learning, natural language processing, and advanced statistical analysis. Researchers around the globe can now download high-resolution scans of the manuscript's pages and apply their own digital tools, hoping that brute computational force combined with clever algorithms might finally unlock its secrets. This has led to a proliferation of new studies and proposed theories. These computational methods are diverse and ingenious. Some researchers use machine learning models trained on vast corpora of known languages to see if the Voynich text exhibits statistical similarities to any particular language family. Others employ algorithms to search for hidden patterns, repetitions, or underlying grammatical structures that might betray the nature of a cipher or a constructed language. And there have been attempts to use neural networks to translate Voynichese, or to determine if the text is meaningful by comparing its statistical properties, like entropy or word length distribution, to those of real languages versus random gibberish. Each new computational technique offers a fresh lens through which to examine the ancient script. While no definitive, universally accepted decipherment has emerged from these computational efforts, some intriguing, albeit tentative findings have been reported. For example, some studies have claimed to identify language-like structures such as prefixes and suffixes or a core vocabulary. Certain analyses have suggested that the manuscript's statistical properties are consistent with those of genuine languages, arguing against the hoax theory. There have been various proposals linking the text to Semitic languages like Hebrew or Arabic, or to East Asian languages, or even to Lost Romance dialects, often based on subtle statistical signals detected by algorithms. However, these results are often contested and lack independent verification or a clear path to full translation. The limitations of purely computational approaches are also becoming apparent. Raw processing power alone may not be enough without a crucial conceptual breakthrough. Many algorithms can find patterns, but distinguishing meaningful linguistic patterns from coincidental statistical noise in a unique, uncorroborated text is incredibly difficult. The garbage in, garbage out principle applies. If an algorithm is based on flawed assumptions about the nature of the text, its results may be misleading. The ongoing debate continues. Is the Voynich manuscript an enciphered known language, an unknown natural language, a sophisticated artificial language, or an artful, meaningless fabrication? The digital detectives are hard at work, but the case remains wide open. Section 9, An Unbroken Silence, the enduring allure of cryptography's riddle. After more than a century of intense scrutiny since its rediscovery by Wilfred Voynich, the manuscript that bears his name remains stubbornly silent. Generations of brilliant minds, from scholars and linguists to master cryptographers and cutting-edge AI algorithms, have attempted to coax its secrets into the open. Yet its elegant script and bizarre illustrations continue to hold their meaning captive. This unbroken silence is a testament to the profound ingenuity of its creator, or perhaps to the sheer chaotic randomness if it turns out to be a grand, artful deception. The Voynich Manuscript stands as one of history's most compelling intellectual challenges, a puzzle that has resisted every key forged so far. In the annals of historical cryptography, the Voynich Manuscript occupies a unique and revered position. It serves as a benchmark for the seemingly unsolvable, a constant reminder that not all codes are made to be broken, or perhaps that our understanding of historical cryptographic methods is still incomplete. It challenges the very notion that human ingenuity can eventually unravel any mystery. For cryptographers, it's more than just an old book. It's a symbol of the ultimate cryptographic test. Its continued resistance fuels both frustration and an enduring fascination, driving the relentless pursuit of new methods and insights in the hope of one day hearing what it has to say. Beyond the academic and cryptologic communities, the Voynich Manuscript has become a cultural icon. It has permeated popular culture, inspiring novels, music, artwork, and countless online discussions. Its mystery taps into a deep human fascination with the unknown, with lost knowledge, and with intricate puzzles. It embodies the romantic idea of a hidden secret waiting to be discovered, a message from the past that could potentially rewrite our understanding of history or some forgotten aspect of human experience. This allure keeps the manuscript alive in the public imagination, a shared enigma that invites everyone to speculate and wonder about its true nature and purpose. What does the future hold for the Voynich Manuscript? Will its secrets ever be unveiled? Perhaps a new discovery, a related text, or a revolutionary analytical technique will finally provide the breakthrough. Or maybe it will remain perpetually out of reach, its meaning lost to time, or forever locked within its unique design. The tantalizing possibility that the key is still out there, perhaps overlooked in plain sight or waiting for a different kind of mind to perceive it, keeps the quest alive. The universe, it seems, has a fondness for enduring mysteries, and the Voynich Manuscript is undoubtedly one of its most captivating literary enigmas, a silent challenge echoing through the centuries.